Hello everyone, welcome to Erdas Imagine tutorials. In this video, I'm going to demonstrate how to perform accuracy assessment using Erdas Imagine. To start with, here I have displayed the original data as well as the classified map using the supervised classification. Please note that in my previous video, I have demonstrated how to perform supervised classification using Erdas Imagine. I hope you already have watched that video. If you have not yet watched that, you can watch by clicking on the link shown in the top right corner right now, and I'll leave the link of the same in the video description below. Coming back to this video, let me now start the demonstration on how to perform accuracy assessment. To start, go to the raster tab here, click on the supervised icon. Down below, you have accuracy assessment button. Click on it. And that will open the accuracy assessment window. Here, currently no file is loaded. So you have to load the classified map to the accuracy assessment. So select the file here. Click on open. Fetch your classified map. Right, now you can see that the classified image's name appears here. For this particular classified image, I will now perform accuracy assessment. We need to now identify a finite number of points from the classified map, and then we will cross-verify the accuracy of each of the pixels classification by referencing it with either the Google map or the Wikimapia maps. Let me first illustrate how to add points from the classified image. Go to the Edit menu, click on that. And here you have three options. The first one is create or add random points, which will enable you to add new points which will be selected from the classified map. The second option is to import the user-defined points. Using this option, you can import latitude and longitude points which all belong to the classified map, and then you can perform accuracy assessment. In the last one, we have class value assignment options. I'll talk about this a little later. Since I do not have a predefined set of points, I'll use the first option here, which is to create or add random points. Click on it. Another window would appear, which is to add random points. Now you have to identify how many points you would like to add for performing accuracy assessment. This is not a straightforward process. You need to have basic knowledge about accuracy assessment. Let me explain that by using the PPT that is prepared here. Right, so in this particular PPT, I have shown how many points must be taken for each class by using a certain accuracy and by assigning a certain percentage of error margin. Please note I have taken this table from the textbook Remote Sensing Digital Image Analysis from Richards and Gia, and this is the 4th edition textbook from the authors. The table 1 here says the minimum sample size necessary per each category, which is nothing but each class, for an estimated classification accuracy of 95% with a plus or minus 10% error margin. This means that you are expecting at least 95% classification accuracy with a plus or minus 10% of error margin during the accuracy assessment. For example, if I want 95% classification accuracy, then the sample size for each category or each class on the classified map must be 60 pixels. Coming to the second option here, if you are expecting an accuracy of 90%, then each class or each category must have at least 30 pixels. Similarly, for 85% classification accuracy, the minimum number of pixels per class must be 20. For 80% it is 15. For 60% it is 10. And lastly, for 50% it is 5. Please note that these statistics were derived from the paper by Van Genderen. For this demonstration, I will be using this table as a reference to add points during the accuracy assessment. Coming back to Erdas Imagine, let us now add points to perform accuracy assessment. The first option here is search count. Every single time the classification accuracy assessment runs, it searches for 1024 points. The second option is number of points totally to be considered for performing accuracy assessment. Here we have taken the number of points as 256. Coming down here, you have the distribution parameters, and we have three types of distributions given. The first one is random distribution. This option collects points absolutely randomly, and it will not consider the class proportions on the study area. I definitely would not recommend this because the second and third options are more preferable. Let me first explain the third option. The third option is Equalized Random. This particular option selects a fixed number of pixels from every class that is available on the study area. Once again, this is also not recommended because we will never have classes distributed equally on any study area. For example, in this particular thematic map what you are looking at, the red colored pixels belong to vegetation, blue colored pixels belong to water body, green colored pixels belong to agricultural land, and it goes on in this fashion. As you can very clearly say here, red colored pixels are in much more proportion compared to either the green colored or the blue colored pixels. So, Equalized Random option should not be selected. What leaves us then is with the second option, which is Stratified Random. This particular option identifies the class proportion on each of the thematic map, and then it generates random points based upon the proportion they appear on the thematic map. Coming back to the table, let us now try to obtain a classification accuracy of 95%. That includes plus or minus 10% error margin. With such a statistic, the minimum number of sample size or minimum number of pixels per each category or class must be 60. So, down here you have an option to select the minimum number of points. Click on it and change the minimum points to 60. This particular setting will then create random points by assigning a minimum of 60 points on the thematic map. In my classified image, there are totally 5 classes. Therefore, with a minimum number of 60 points and each of them distributed for 5 classes, I must have 60 multiplied by 5, which is 300 points. So the total number of points here should be reset to 300. However, if I set it to 300, then it would be assigning equal number of points for each of the class on the thematic map. Since we have selected Stratified Random, the number of points here must be considerably higher than the minimum number of points as per 60 multiplied by 5 classes. So what I would do here is I will change the number of points to, let us say, 1000. Once that is set, we have to next select the classes which we want to perform the accuracy assessment for. Click on this Select Classes button. Another window would appear here. You can see we have classes listed in this particular column. It is very important that you note down what is the row number for each of the considered classes here. Out of these 13 classes, only 4 classes will be of any use to us. These are vegetation, scrubland, agricultural fields, and water body. Now, to select only these rows, press and hold the Shift button and select the corresponding rows carefully. Once that is done, you come back to Add Random Points window and then click on OK. When you do that, you will note that points with certain latitude and longitude will be added to the accuracy assessment window. And if the search count exceeds 1024, you will get this small window. Here you are simply supposed to click on Yes. Keep clicking on Yes until it provides that prompt. Right. Once that is done, come back to the accuracy assessment table. Let us now enlarge this a little bit. Let us now look into how many pixels are generated in total. Scroll down here. You'll see that the total number of pixels is 1000, which is exactly the value I set. Now, to perform accuracy assessment, we have to identify what these pixels are classified as. So in order to identify what classes these pixels belong to, go to the edit menu and here click on show class values. When you do that, you will note you will get this particular column with values filled as per the row number of the classes that we selected during setting the points. As I said, you should know what these numbers represent. If you have not noted down, no problem. Once again, go back to edit, click on create or add random points and then click on select classes here. And now you can note down what these class values are. I'll now create a small text file to note down the class names and the corresponding row values. Okay, so once we have noted that, we can now start performing the accuracy assessment. Go back to the main window, resize it so that you can view all of these windows together. You need one more window here. Go to home, click on inquire, and that will enable the cursor. Zoom to a pixel level. Now what we should do is, we should take these x and y values. We should substitute them here. When I substitute here, then the Erdas imagine will point to the corresponding window. We should do this, please note, on the original data, not on the classified map. And then we have to now cross-reference this pixel with either the Google map or the Wikimapia map. Let me now show that for pixel 1 here. The x value for point number 1 is 1691.000. Come back to the inquire table here and give those values. Coming back here, y value is 1064.000. Once you are given that, press enter. So this is the pixel under consideration now. Now I have to identify what this pixel belongs to. If you are quite sure about what this pixel belongs to, by just looking at the original data that was used for classification, then there is no need of cross-referencing with either the Google map or the Wikimapia map. However, if you are not sure what this particular belongs to, then you need to cross-reference. Here, for this particular pixel, when I zoom it out, I note that this pixel belongs to vegetation. Because when I was training, the red colored pixels and these bluish pixels were both considered for vegetation. So what I should now do is go back to the text file, identify the number for vegetation, which is 1, come back to the accuracy assessment window, and in the last column, which is a reference column, you write 1, press enter. So we have now verified what pixel 1 belongs to. The classifier thinks it belongs to class 1, and we have verified that it in fact belongs to class 1. Now move on to pixel 2. Once again, go back to the inquire window and give the values for x and y. The x value is 2121 and the y value is 246. Press OK and you can see it has now moved on to a different pixel. Zoom and you will identify that this also is a red colored pixel, and all the red colored pixels were considered as belonging to vegetation during training. So in the second row, I'll once again give the class value as 1 because that is what represents vegetation. In this fashion, you need to now continue performing this operation for all the pixels in the accuracy assessment table. You can save the table at any instant of time by just going to the file and clicking on Save Table. So next time you open it, the previously entered values will be already there. Now let me illustrate how to perform cross-referencing with Wikimapia. Let me now demonstrate cross-referencing for pixel number 8 because the classifier thinks it belongs to class 13 and class 13 is water body. So go to the inquire table, give the x and y values for that. It is 730 and 675. Okay, so this is the pixel. Zoom out. Right, by looking at this particular pixel, I know that this pixel belongs to a water body. You can see it is actually on an estuary created by a river. However, let us now cross-verify using the Google Maps. The problem now is when you are performing accuracy assessment, you have the values of X and Y based upon the location of the pixel on the data. These values of X and Y are not recognized by either the Google Maps or Wikimapia Maps. What those maps recognize is lat and lon. So to convert these values to lat and lon, simply come back to the file option here, click on it and change it to lat lon WGS. So you can now see that you get the latitude and longitude. You can change these to obtain values of your own choice. What is most suitable here is these values, because this is exactly the format in which the Google as well as the Wikimapia maps take the latitude and longitude values. Let me now show that to you. Right, now I have opened wikimapia.org. This is not the satellite map, so go to this icon here and click on Wikimapia satellite. That will change to satellite map. Now we want to provide the latitude and longitude values of this pixel to Wikimapia. How do we do that? If you come to the address bar, you will note that you have some numbers, 13.35, then we have 74 point so and so. So these are our latitude and longitude values, and currently if you zoom out properly, there is a plus mark here, and these latitude and longitude values are representing this pixel on the plus mark. You can zoom as much as possible. However, please do not use the zoom using the scroll button, because if you change the location, then the zoom location will change. What I suggest is to use this scroller, which is given by the website itself. Now let us go back to the inquire window, which is this one. This pixel's latitude and longitude are given here. Copy them. I'll select the Y value first. Go to Wikimapia, double click, it will select only that number, then paste. Don't press enter as of now. Come back, copy the X value, go back to Wikimapia, select the other number here, paste. Now press enter. And now the Wikimapia will take you to the pixel under consideration. So you can now see that here, this particular pixel, let me zoom in a little bit, belongs to water body. So once you have verified that this in fact belongs to water body, come back to the accuracy assessment table, and you have to now give the number here which indicates water body. As per my text file here, number 13 represents water body. So come back and write 13 here, press enter. This indicates that the classifier as well as the user both agree that this pixel, which is pixel number 8, belong to water body. In a very similar fashion, you need to continue the process for all the pixels that are listed under the accuracy assessment table. The process is quite tedious and time consuming. However, you have to be patient, because the accuracy of the thematic map depends upon the values that you provide under the reference table. Right, I hope that now you have understood how to perform accuracy assessment. To complete this demonstration, what I will do is, I'm going to delete all these pixels and I'll consider only a finite number of pixels, in fact a very small number of pixels, so that I can show you how to generate the accuracy assessment report. If you want to delete either one pixel or multiple pixels, what you should do is select, drag your mouse, right click, and then there is an option to delete selection. So that will delete those pixels. For my demonstration here, since the number of pixels are very large, what I will do is, I'll click here, right click, select all, and select those pixels which you do not want to delete. I'll only consider 15 pixels here. Scroll down. Now these are all selected. Right click and then click on delete. So right now I have only 15 pixels. Now to quickly demonstrate how to generate the report, let me now assume that all of these classification results are accurately done. So I'm going to just retain the values what is already suggested by the classifier. However, for this pixel, that is pixel number 13, the classifier thinks it belongs to class 10, which is agricultural fields. However, while cross-verifying either using the Wikimedia or the Google Maps, you found out that it does not belong to agricultural fields. In that case, you have to give your input. For example, if you think it belongs to vegetation, then click on the number that represents vegetation here. Let me complete this table now. Right. So now I have verified all of the pixels in this table. Please excuse me, when I was creating this text file, I have set class 8 as belonging to vegetation. Class 8 was actually barren land. Okay, please make that note. Okay, now coming back here, we have found that out of 15 pixels, 14 are correct, but one of the pixel is wrongly classified by the classification technique. To generate a report on this, what you should do is go to the report menu and then here click on accuracy report. It will generate a text report here. The first thing you should do here is to save the file. So go to File, Save As, go to the location wherever you want to save this file. I'm saving this on the desktop. Give a file name. I'll say classification accuracy. Okay, I've saved it. Now I can close it. Come back to the file. Now let us see how the accuracy assessment report looks like. I'll select Notepad to open it. Right, so you can now see that we have a large error matrix generated. I'm not going to discuss how to simplify this error matrix as of now. I'll discuss that with complete detail in my next video. What is important to us here is the overall accuracy. So you have to now scroll down as much as possible. Right, so somewhere here I have what is called as overall classification accuracy, which is 93.33%. If you look at the final values for totals here, you have, which indicates 15 pixels were considered for accuracy assessment. All of those 15 pixels were considered for classification by the classification algorithm, and only 14 of the 15 pixels are correctly classified. So the overall classification accuracy is simply 14 divided by total number of pixels considered for accuracy, which is 15. That will give you 93.33% of classification accuracy. This is one of the most important metrics in analyzing the thematic map accuracy. Another important thing that is generated during classification accuracy assessment is the overall Kappa statistics. Let me now very briefly tell you what this Kappa statistic means. Please note, while performing accuracy assessment, I have selected only 15 pixels. However, the total number of pixels on the thematic map is considerably larger than the number of pixels I have considered. So what about the pixels that are not considered during the accuracy assessment? To analyze the accuracy assessment of those pixels which were not used during the accuracy assessment, we will use extrapolation technique. And the metric that we use to analyze the extrapolation accuracy is the Kappa statistic. I'll explain more about what is Kappa in my next video when I explain how to analyze the accuracy assessment results. However, I will give a very brief introduction to what is the expected value of the Kappa statistic range. Right, in this table, I have listed the suggested ranges of Kappa coefficient and what actually that particular Kappa coefficient means in literal terms. For example, if the Kappa coefficient value is less than 0.4, then the classification can be regarded as poor. The value of Kappa coefficient from 0.41 to 0.6 is considered as moderate classification. 0.61 to 0.75 is considered as good. 0.76 to 0.8 is considered as excellent. And any value of Kappa equal to or above 0.81 indicates the classification is almost perfect. So, quite obviously, while performing accuracy assessment, you need to target the values in the last row here. Well, that is about a very brief video on how to perform accuracy assessment in Erdas Imagine. In my next video, I'll be discussing on how to analyze the classification accuracy report that is generated by the Erdas Imagine. So stay tuned. Well, if you found this video to be informative, kindly like and share this video and subscribe to my channel for more tutorials on Erdas Imagine. Thank you for watching. Have a good day.